For a standard normal distribution, find the z-value that corresponds to the upper 89.3% of the data. All right, so the first thing we want to know about standard normal distributions is the normal part means that it's bell curved, and the standard part means that the mean is 0, the standard deviation is 1, and the horizontal scale are z-scores. So if you go 1 standard deviation above the mean 3 times, you get these values, positive 1, 2, and 3. And then going 1 standard deviation below the mean is -1, 2 standard deviations below the mean is -2, and so on. Once we know that, we can look next at the information that was given here is a percentage, and percentages are another way of representing probabilities. And probabilities, when it comes to a continuous probability distribution like we have here, will be areas, or represented by areas under the bell curve. So we would convert this to a probability of 0.893. And you can do that by dividing by 100 or just moving your decimal place twice to the left. And then we also want to make sure we pay attention to the fact that it says upper, so we know that this is going to be a right probability. Now, if we were to place our boundary, our z-score boundary right at the center, then the area to the right would be only 0.5. So that means we know that we need to put our boundary much farther to the left to allow for a much larger right area. So with an area of 0.89, and I'm just kind of getting an idea of how that looks. I don't have to get it exactly right, but I do know that I am going to have a z-score that is negative because it has to be allowing for an area that is greater than half of the area under the curve. And remember, the whole area under the curve is a total of 1. So now that I have a general idea of what my answer should look like, I can now use the inverse function, the norm.inverse function in Excel, and enter a left probability. Okay, this is an important thing. They've given us a right probability, so I need to subtract that from 1 so that I can enter the left probability, since that is how the formula is set up to work. So I'm just subtracting it from 1, as you can see in the first argument of the norm.inverse function. Then I'm putting in the mean of 0 and the standard deviation of 1. And remember, I knew that the mean was 0 and the standard deviation was 1 because we're talking about z-values and a standard is the key word here, normal distribution. All right, and so that is how you would get your answer using Excel. You could also look up this area, or actually the left area, in the body of the z-table. And so what is 1 minus 0.893? Let's just do it over here. 1 minus 0.893 is 0.107. So I could look into my z-table, look up the middle, and look for that number 0.107. And again, I knew I was looking in the negative z-score table, but even if you didn't know that, if you tried to find this area 0.107, if you were to try to find that in the positive side of the z-score, you will not be able to, right? It's only your z-score tables, if they're set up like mine is, with areas to the left, with a negative z-score table and then a positive z-score table. All the areas in the positive z-score table will be greater than 0.5, and all the areas in the negative z-score table will be less than 0.5. So I'm only going to find 0.107 in the negative z-score table. So let's find it here. 0.107. I have some highlighting from a previous problem here. Let me get rid of that. 0.107. So what's the closest thing to 0.107? I see, not even close, am I? 0.1075. I guess this would be the closest one. And so sometimes these problems are better to be answered with technology because the z-score table is based on rounded values. And so sometimes you lose accuracy that can affect whether or not you get the answer correct. but I would go with this as the closest possible area to what we need, and then look up the z-score as negative 1.2, and then the last digit will be 4, so negative 1.24. And so you can see that if I rounded my answer that I got from using Excel to 2 decimal places, I would have the same answer that I got from the table. But just make sure you're paying attention to any round off recommendations, or if it were to say don't use the z-table or don't use technology or use one of them, just pay attention to how the actual problem asks you to enter the answer, and you should be good to go.